Hello, everybody. Thank you for letting me speak today at the 2021 edition of the Career Material Handling Show. I'm very sorry I can't be there in person with you. The Career Material Handling Show is one of my favorite events of the year, and I wish I was there with you in person and hope to be there next year sharing with you together with all the new ideas and exciting things happening in our industry. Today I'm going to talk about data-driven design. But before I do, I'll just introduce myself and my company so that you know who is speaking for anyone who has not yet met me. So LIDD Consultants is a global supply chain firm, and my name is Charles Fallon. I'm the president and founder of LIDD Consultants. We have 4 offices across Asia and North America, Seoul in Asia, and Los Angeles, Toronto, and Montreal in North America. We have about 100 employees and consultants working across those offices and helping our manufacturing, wholesale, and online and offline retailers with their logistics and distribution challenges. To date, we've done about 700 projects since our founding in 2010. So to put this speech in context, why don't we start with what are some of the key trends in distribution today? The obvious and largest trend is that the coronavirus has accelerated the widespread adoption of e-commerce. Everyone in a range of industries has had to rapidly deploy increased capacity to serve the direct-to-consumer channel, or they've actually started for the first time through this pandemic as a way of making sure they maintain a link to their customers. Within the direct-to-consumer world, however, whereas maybe 5 years ago, next-day delivery would have been considered state-of-the-art, best-in-class, today consumers are much more demanding, and they're looking for hyper-local solutions where they can expect service levels of next-hour delivery. Within the 4 walls of the distribution facilities, we're seeing a new generation of automation arise, where the first generation that we've been working with for the last 10 to 20 years consists of these large installations of very inflexible solutions that cost a considerable amount of capital. The second generation, the new generation of automation coming online, is lighter in footprint, more flexible in solution, and more collaborative in terms of how it integrates with human-driven systems. And the last trend I want to identify and bring up here is the blur of the distinction between a manufacturing site and a distribution site. Fulfillment centers increasingly are playing a role where the manufacturing concepts and technologies must be deployed for them to fill their mission. All of these trends create increasingly complex supply chains where companies can no longer make decisions based on instincts or habits. Companies must make use of their data to drive optimal decisions in process engineering, material handling, and fulfillment center layouts. And that's what brings us to what I call data-driven design. Every fulfillment center in the 21st century is running with some sort of warehouse management system. And therefore, in the digitized environment that we operate, we are creating vast amounts of data, transactional data, every time we receive, put away, pick, or ship product. This transactional data, combined with the master data that we use to run these systems, allows us to harvest and model the data to make better decisions about how we design facilities, how we process engineer the tasks within the facilities, and we eliminate or filter out opinion, instinct, and habit from our decision-making process. What I thought we would do today is we'll go through 3 case studies where data was used to make a better decision about how to set up a distribution operation. And our first case study is with a client of ours who was about to take in a new line of business in their fulfillment center. And while they were thrilled with the new volumes, it created a challenge. The challenge was that the new items they would be adding to their fulfillment center were greater than the available pick slots they had on their pick line. Now, up until this point, they had only used pallet slots, as you see in the top right corner of this slide. And they were reluctant to use smaller slots like case flow racks, as you see in the bottom of the slide, because they felt that the replenishment work into maintaining the case flow racks would be too much work, too much labor to be worth it. So we decided to use the data and let the data tell us what we should do. Before I get into that data analysis, I do want to make one point about pick slots and particularly around ergonomics. Ergonomics is not just an issue of safety, although that's very important, and reducing worker injury, which is very important, but it is one of productivity. And when you look at the pallet slot and the case flow rack, they're not equal. In the case of the pallet slot, about 50% of all picks coming from one of those slots is in a poor ergonomic position, where particularly a picker has to bend and lift at the same time and be carrying a weight well past their center of gravity. Whereas in the case flow rack, virtually every pick that the picker has to make is in an ergonomic position, comfortably able to handle it and minimizing the injuries and strains that come from repetitive motion. I just thought that would be an interesting point to make. It's often forgotten, but on with the data analysis. So the issues between a case flow rack and a pallet slot is, on one hand, you must invest much more labor to replenish the case flow rack. However, the amount of pick line that a pallet slot occupies is considerably more. So as you can see in the table, we just did the analysis of calculating how much picker travel we would create for 2,500 orders a week if we slotted the pick line as pallets versus case flow. Then, looking at the kind of volume per SKU, we looked at how many replenishment tasks and therefore how many hours of replenishment would be needed to keep both those pick lines running. And when we looked at the total, we saw that the case flow racks were considerably more productive than the pallet slots, and therefore recommended introducing some case flow rack slots. However, there is one thing I'd like to point out. That is not a conclusion that everyone should walk away with and say, well, that means case flow racks are always better and pallet slots are always less productive. And the reverse is equally untrue. The point is, you have to look at your own data and do the analysis. So on this table, you can see that as volumes increase, the relative advantage of pallet slots increases. And as volumes decrease, the relative advantage of case flow slots increases. And in this particular instance, when the pick line hit roughly 10,000 cases per week, at that point it would be more productive and more advantageous to slot everything in pallet slots. The key message, the data tells you the right answer. And look at your data when you're analyzing these things. In the second case study, we had an e-commerce company, distributor of some form of toy that was at capacity in its conveyor system. They were growing rapidly and they needed a solution to add capacity to the conveyor system. Now, the easy answer is to launch a large expansion of the conveyor system, but that's extremely expensive and would be terribly disruptive to the operation. So before engaging in that large and painful project, we looked at the data to see if there was any other kind of change that could be made to alleviate the capacity constraints on the conveyor system. So when we looked at the data, we saw that 29% of the orders that they shipped, the 9,000 orders they shipped every day, 29% of them had only one order line. So if you could picture that as we try to illustrate here on this slide, 1 out of every 3 totes on the conveyor system had one item in it. Essentially, they were empty totes, occupying 60 centimeters, 90 centimeters of the conveyor for almost all empty space. And that we thought we could probably do something about. So here's what we proposed. When a wave of orders is dropped into the WMS, we would isolate the one-line orders. We would create a batch pick task for those orders. So the first totes in that wave would not be for any given order, but would be for a batch of one-line orders. And pickers would pick into those totes. Those totes would fill up, and we would send those full totes to a dedicated packing station where, once arrived, packers would prepare the individual orders at the table. And what this allowed us to do was remove almost 20% of the conveyor traffic on the conveyor line and increase the capacity of the conveyor system sufficiently to avoid a large, expensive expansion of the conveyor system. This was done with a very minor adjustment to the packing area, with a very minor adjustment, in fact creating just a new order picking task in the warehouse management system at a cost far less than the expansion, with minimal disruption to the operation. The third case study that I want to talk about is in online grocery. Now, all over the world, online grocery is booming because of the coronavirus pandemic largely. But as people are seeing the convenience and quality of product that is arriving at their doorstep, increasingly people are seeing this as a legitimate option going forward to make their lives more convenient. What makes online grocery very complicated is the size of the orders, which can be here in Korea, averaging 9 to 12 order lines per order, to the North American order size, which is actually 22 to 30 lines per order. And then the other challenge is the vast number of SKUs that grocers offer their clients. It could range from 10 to 40,000 SKUs across multiple temperature zones. Now, when we look at those SKUs, we see that they are not all created equal. Customers want a very wide selection of product from their grocers, but they rarely order the vast majority of items. So when you look at the volumes in total, half the items in the warehouse only ship about 4% of the order lines. In fact, on the right-hand side, you'll see a graph that shows the first 5 to 20% of the items. That's 80% of your volume. when you're automating a large online grocery facilities, that first 80% of the volume is fairly easy to automate and create a highly productive system for. The challenge is then to create a productive system for those 80% of SKUs that are just 20% of the total volume. The other challenge when you look at it is about that order size being very large. It's not just the case that the slow movers generate a few order lines, but those order lines are dispersed among many orders. So in fact, even though it's a small number of order lines generated from the slow-moving SKUs, you find slow-moving SKUs on almost every single order. In fact, in this situation, about 4 out of 5 orders required a slow-moving order line to be completed. How do you create a highly productive, with a very good throughput, how do you create a solution like that when I have to send a lot of traffic in terms of outbound totes to a slow-moving pick zone for a minimal amount of order lines? Well, one approach is to spend tens of millions of dollars on goods-to-person solutions for this. But there is another solution that is quite a bit less expensive and equally effective, and that involves consolidating slow movers, as I'll explain on the next slide. Conceptually, the solution would be to remove the slow movers that we need in an order wave and deliver them to the fast-moving picking zones that are already highly productive, capable of handling large output. So we remove these slow movers from the picking zone in a batch. In other words, if I am releasing a wave of orders that represents 6 to 10 truckloads, delivery truckloads, I want to pick all of the slow movers for all 10 truckloads in a single assignment and deliver them in such a way that I can easily separate and identify which ones go in which outbound totes. And I'm going to show you how we do this on the next slide. If we look at this slide, and starting on the left is a pick tower. And the pick tower consists of 4 floors. The top floor is just a simple shelving arrangement where I will put 10 to 15,000 slow-moving items. I will pick them manually with a cart and invest very little capital in those items. And if I follow from the top right and going down, let me explain the process. An order wave will drop and the slow movers will be picked 30 minutes ahead of the fast movers. Batch pick assignments of these slow movers are sent to the 4th floor where they are picked, as I said, in batch into totes, and the totes are sent to the induction point of a sorter, a unit sorter. The unit sorter sorts each individual slow-moving order line into chutes, and the chutes have as their destination each a fast-moving pick zone. Thereby, by the time the fast-moving pick zones begin picking that wave of orders, the slow-moving order lines are already placed, ready to pick in the fast-moving zones. And they were placed there by a unit sorter, not a human. When the outbound tote arrives in the fast-moving zone, not only can the picker pick what is slotted in that zone, but any outstanding slow-moving order line that has to go into that zone. So as we come to the end of this presentation, I want to take first a quick look into the future. Lots of folks have been interested in and deploying goods-to-person systems such as the AutoStore, the automatics, or the Ocado system. And again, when we're thinking about using these systems, we're going to get to a limit of their output by just going with our gut instinct on how to set them up. But once we start to harvest our data and deploy analytic approaches like queuing theory to these systems, we will be better able to get higher productivity and higher output from these systems. In fact, ultimately, we're going to lead to algorithms that are going to make real-time solutions while in production from these systems to make them perform better. So finally, I'm going to conclude. As we agree, I think we all agree, the coming years, the supply chain is going to get more complicated, and our operations are going to have more demands placed on them. And in the digitized fulfillment operations that we all operate, we're generating huge amounts of data that can be so powerful and so insightful if we use them to our advantage. We looked at 3 simple case studies today to illustrate how data analysis leads to better designs and better processes. We saw that slotting isn't a matter of opinion, and that actually the trade-offs between replenishment and picking should be studied and modeled using data, and let that drive the decisions. We saw how a simple analysis of the order profile in a conveyor system allowed us to make a modification to process to increase capacity on that system without having to spend a whole bunch of capital on expanding that conveyors. And then in the last case study, we leveraged some of the data challenges, or some of the challenges of slow-moving products and fast-moving pick zones in order to eliminate what ends up being a very expensive capital investment, automating slow movers when they only represent 4% of sales coming out of an online grocery facility. And as we look to the future, we want to see data analysis and the ability to take real-time data and make tasking decisions with that real-time data to make our operations even more productive in the future than they are today. I want to thank you very much for listening. I wish you all a wonderful rest of the Korean Material Handling Show, and I look forward to seeing you all next year.